Good day, ladies and gentlemen. Thank you for being with us. For the next session, I will be presenting about AVO 101, everything that is to know about Class 3 AVO and its application in the Ketaling Field, Jambi. This paper was authored by myself, Enik, and also my teammate from PERTAMINA EP. Okay, this is a brief profile of myself. My name is Enik Lestari. I'm from PERTAMINA EP. I have educational background from Geophysics Gajah Mada University and also Petroleum Geosciences, which is a double degree by ITB and UKM. And I've been working with PERTAMINA EP for more than 10 years. For the first 3 years, I've been working evaluating West Java Basin. And since then, I've been evaluating Jambi and also Palembang Sub-Basin. So this presentation will cover some outlines, started with the introduction, and then AVO basic concept to refresh our understanding of the AVO, and then methodology, where I will explain what we have completed in the study and followed by analysis and discussion, and of course a summary to conclude this study. For introduction, I would like to give some fun facts of the Ketaling Field. Ketaling Field is located in the Jambi province, about 37 away from Sultan Taha Airport to the east. Ketaling Field is currently producing oil from Batu Raja carbonates. Upon developing this carbonate reservoir, a shallower upside potential was encountered, and it was a gas-bearing sandstone. This gas is needed to be mapped as soon as possible to enable near future utilization to power the field. When talking about gas reservoir and then sandstone reservoir, what first came to mind was AVO method. Why AVO? Because AVO has some success stories being applied worldwide. Like these are the first few examples of the AVO success stories. The first one was from Norway, where AVO method as fluid distinction was useful for identifying the presence of different fluids. And then the second one in Texas, AVO as fluid detection was successfully detecting hydrocarbon using product and then a gradient of AVO and intercept. And the third one is from Ukraine, where AVO analysis worked correctly on the gas condensate reservoir delineation. Why AVO is really? AVO by definition is amplitude variation with offset. When we have a point in the subsurface, which is shot by several pairs of source and receiver here, or we call it offset, we will have traces recorded here on the right side with amplitude varying depends on the angle of the incidence. How does AVO work? When we have a normal incident where the ray comes into a layer, into a boundary of two layers in a zero angle, we will have coefficient of reflection, which is the difference of the two impedances over the summation of the two impedances. However, when we have a non-normal incidence or the angle of incidence was not zero, the coefficient reflection is more complicated to estimate. Zurprit has approached to resolve this equation by elaborating elastic wave equation and their solution into a matrix with 4 unknown variables. But don't worry, we are not going to deep dive into the matrix because thanks to these guys here, the equation has been simplified into a more practical solution. Here we have the amplitude as a function of the incident angle, where for intercept and gradient analysis, we have here A is the intercept, which represents the amplitude at a zero offset, and also the second term here represent the change of the amplitude toward increasing angles. Next, we will proceed into the methodology. Here is the data available in the study and also the workflow we have completed during the study. Started with the well log and check shot. We conducted the petrophysical analysis to detect the gas interval or the pay zone. At the same time, we also evaluate the seismic gather and conducted some preconditioning into the data. Once the wavelet is extracted, a seismic well type procedure was conducted. And then the next step, we do some fluid substitution modeling, where in few scenarios are incorporated by substituting the fluid contained in the reservoir. This is to see the response of the reservoir with different fluids content, and to see the response and then the cross plot, and finally determine their AVO classes. At the same time, CDP gather from the AVO was also analyzed for their intercept and also the gradient. And once we have the same classification of the AVO anomaly, we generate the AVO volume attribute. And once we have the horizon interpreted previously, we can extract by horizon slicing, for example, to result the AVO attribute maps. These are the data we were talking about. This is the full stack seismic section, pre-stack seismic section. The brightest amplitude in the lower part here represents the batu raja carbonate, which is producing in the other part of the field, where our focus here is the gas-bearing algae sandstone, represented by the high negative amplitude colored in blue. This event corresponds to this log response here in the well, where we have slight drop in the P wave and also density, and where the cross plot of the VP over VS to the P wave falls into the gas sandstone area here. And then the next, before conducting the AVO analysis and classification, what we do is basically pick the amplitude value here over their offset and then plot them into their respective offset. And once we have the plot, we can determine what class of AVO anomaly they are. And this is also one of the analysis method in the AVO methodology. We also plot the intercept over the gradient of this event to determine where they fall within this four area. And then we will focus on the Class III AVO itself, where this sandstone belongs to. Class III AVO is indicated by negative reflection coefficient at zero offset here, and amplitude is getting negatively higher with increasing offset. This is a typical low impedance gas sandstone where relative impedance is lower than overlying unit. And mostly, Class III AVO appears as bright spot on the full stack section and on all the angle limited stacks. Okay, we'll proceed to the analysis. In the analysis, before we conducted AVO analysis into our seismic data, the first thing we did was conducted a feasibility study, where here we have modeled traces with different fluid content in the reservoir. The first one here, the leftmost is traces respond with 100% of gas saturation, and then followed by the 100% water and in situ condition here in yellow was representing a 60% of gas and 40% of water. We can see the response here that model with gas content tend to have similar response, where they have negative amplitude at the intercept and then getting higher in the far offsets. While the one representing water in the reservoir here is indicated by the positive amplitudes all the way to the farthest offset. And also here is the cross plot of the intercept and gradient, both with gas content, falls with significant offset from the wet line trend here, compared to this one here is brine or water filled reservoir. So this is the analysis of the real seismic traces, which coincides with the seismic with the well location here. We have picked the event, and we also have here a negative amplitude in the intercept, and it is getting negatively higher and higher with the increasing offset. And the cross plot also indicate that this seismic response falls into this zone here, where we have quite significant offset from the wet trend line. This is very well goes with the model we used before, where we also have this point here representing reservoir with gas. This is the AVO volume attribute that we generated once the analysis was done. It is called the scale Poisson ratio change, which is here showing the gas saturated sandstone, while in the left figure here, and we have this section across the anomaly here also represents the Poisson ratio change in the reservoir filled with the gas. This mapping also validated by well test result, DSTs, from 3 wells, where the 2 of them falls into the anomaly of the AVO, where gas was also plumbed during the test. And here we have 1 well, which is outside of the AVO anomaly, with test result was water and oil traces. And for summary, we come up with conclusion that AVO, showing the variation of the amplitude with varying offset, is prominent technique in detecting hydrocarbons. And then the second one, understanding AVO principles and techniques will help interpreter analyzing seismic data for AVO anomaly. And the last one, AVO attribute mapping has successfully delineated gas-bearing sandstone in Ketaling area. And here to close my presentation, I have some quotes by Nino Farsimasili. Sometimes little changes can make difference, which refers to actually to one of the pitfall of the AVO method, where even small gas saturation can have big amplitude response in our seismic. I think that's all. Thank you for joining us. Good day.